In this video, we're going to take a look at the concept of pressure. And pressure is a measurement of force per unit area. So P is equal to F over A. So if you think about it, what you basically have inside of a balloon is you have little molecules that are hitting off of the sides, and those impacts apply the pressure. And then on the outside of the balloon, you have air molecules hitting off the outside of the balloon. And when those two forces are equivalent to each other, the balloon has this sort of static volume. So that gives you an idea of what pressure is. It's the force of the impacts of the gas molecules inside of their container over the area of the container. So a good question is how do we measure pressure? And the answer to this is there's several ways to do this, but a common way of doing this is through what we call a manometer. And basically what a manometer is it's a tube that's inside of a container of liquid. And there's liquid in the tube, and there's liquid in sort of this container, and the atmosphere pushes down on the liquid in that container, and that applies a force on the liquid molecules, and it pushes them up into the tube. And then eventually what happens is the weight of the molecules of water inside the tube gets sufficient enough that it equals out with the pressure of the gas molecules pushing up on the tube. So you basically have, at the interface inside of that tube, you have your water molecules. So you have the air pushing down, and then you have the weight of the water, or the mercury could be, pushing against it and back. So when this thing comes to equilibrium, the height of that water column is going to be proportional to the pressure of the outside air. So when the air pressure of the atmosphere goes up, it'll push that water column up a little bit because you need a little bit more water in there, or a little bit more weight of water to compensate for it. When the air pressure goes down, the water column drops a little bit because you don't need as much water there to push back. There are a couple of different units of pressure, and this allows us to quantize pressure. Some common examples are millimeters of mercury. So a millimeter of mercury, and this kind of makes sense because remember we were talking about heights. So this is how high up a column of mercury would be as it's pushed down on by the atmosphere. So it turns out that the millimeter of mercury is equivalent to a torr. So one millimeter of mercury is equivalent to 1 torr. And there's another unit called an atmosphere. So 1 atmosphere is equivalent to 760 millimeters of mercury. And it's also equivalent to 760 torr, because remember, for every 1 torr, there's 1 millimeter of mercury. And there's one other unit, and this is the Pascal. So the Pascal, if you want to put this in terms of atmospheres, an atmosphere is equal to 1.01 times 10 to the 5th pascals. And there's also a unit called kilopascals. That's another common unit, and that's just pascals, but with the little k in front of it, giving it the kilo prefix. So using these unit conversions, we can do some converting. So for example, if we wanted to do 250 torr to atmospheres, we can do that. We know that for every 760 torr, there is 1 ATM, and this is something that you should memorize, or if you don't memorize it, you should have it on hand because we're going to be using this a lot. So what you do is you take 250 torr, that's where we start, and we know that there are 760 torr for every 1 atmosphere, and so this is going to equal 0.329 atmospheres.